Hi girls, you're very welcome. We're going to just do a quick recap, I suppose, of turning atoms into ions and how we do that. So what I wanted to do was just to very quickly recap how that process works. Okay, so what you might need in front of you to help you with this is a periodic table. And what we're going to do is we're going to have a quick look at each group and how we turn the atoms in each group into ions. So what I've got in front of me here is I've got the first three elements, can you see that, of group 1. So this is lithium, this is sodium, and this is potassium. And these are the atoms. I've drawn the atoms of each. Now again, you should all be able to do this at this stage, third years. So this is a lithium atom. It's got 3 protons, 4 neutrons, and 3 electrons, okay? An atomic number of 3, a mass number of 7. Again, you can pause this and find that yourself in your own periodic table and even try and draw these atoms first if you want, if that helps. Okay, but now what I'm going to do is I'm going to turn this atom into an ion. Now, what does that mean? Basically, ions are atoms that have a full outer shell. Remember we talked about that atoms want to be happy, was the word we used, to be stable, in other words. And how do they do that? They get a full outer shell. Okay, so you need to remember that to fill a shell, this atom will either gain 7 electrons or lose 1. Now, there's no way it's going to gain 7 electrons. That would be far too difficult to do, and energetically it wouldn't make any sense. So it's much easier for it to lose this 1 electron. Okay, so I'm going to get rid of this electron here, as you can see. All right. And now that that electron's gone, it no longer has 3 positive protons and 3 negative electrons to balance that charge. It's still got 3 protons because they're still there, but it doesn't have it now only has 2 negative electrons. So overall, it's got 3 pluses, but only 2 minuses. So it's now an ion. It's got a charge, and we draw that like this. We put brackets around it, and we put a plus sign like that. And that's now a lithium ion. And sometimes we draw it like this, with a lithium sign and a plus beside it like that. We can do the exact same thing with sodium. Here's a sodium atom. Again, it's got 1 electron in its outer shell because it's in group 1. So we're going to get rid of this here. And now it's still got 11 protons. You can see that in the nucleus. But now it's only got 10 electrons. And again, you should try and do this yourself and draw it as I'm doing it if you don't believe me. And you can see now it's still got 11 protons, but now only 10 electrons. So he's now got a plus charge as well. So we've turned that sodium atom into a sodium ion. And finally then we're going to do potassium. Potassium is 19 protons, 20 electrons. So we're going to do the same thing with that. I'm going to get rid of this outer electron, 1 in its outer shell. I'm getting rid of that, rubbing out the shell because it's empty. So now he's got a full shell, but that means he's still got 19 protons, but only 18 electrons now. So he also has a +1 charge like that. Forgot to put the plus in sodium, didn't I? So there we go. There's the plus in sodium, the plus in potassium. And again, we can draw that like that. So the takeaway message here is that all the elements in group 1, when they form ions, have a +1 charge because they've all lost 1 electron. All right, now let's have a look at group 2. Group 2 elements are here. This is beryllium, magnesium, and calcium. Again, you can follow this in your periodic table. And again, it might be an opportunity to pause the video and try and draw these 3 atoms as I've just done here. As you can see, 4 protons for beryllium and also 4 electrons. So again, we're going to have the same issue. We're going to try and turn this atom into an ion, give it a full outer shell. It's not going to gain 6 electrons. There's no way that's going to happen. It's going to be much easier to lose 2. So that's what we're going to do. I'm going to rub out these 2 electrons here. And now he's got 4 protons still, but now he's only got 2 electrons. So this time the ion has a charge of 2 plus, because there are 2 pluses more than there are minus electrons. Remember that electrons are negative. So we've gotten rid of 2 electrons, still got 4 protons. So overall, it's got a 2 plus charge. So we can write that, if you can see that, like this. Is that okay? Yeah, we do the exact same thing with magnesium. Magnesium is 12 protons, 12 electrons, but we're going to give it a full outer shell, turn it into an ion by getting rid of these. So I'm rubbing out that outer shell like that. And now we've got, again, 2 plus. Same amount of positive protons, 2 less electrons. Those negatives are gone. So it's now 2 plus. So we write that like that. And we do the same thing with calcium. Again, getting rid of those 2, rubbing out the outer shell. We've got rid of 2 minus negative electrons. Still got 20 protons, but now it's only got 18 electrons. So overall, 2 plus charge. So again, the moral of the story is Elements in group 2 form ions which have a 2+ charge. You can see that there. Okay, each of those forms a 2+ charge. Right, so let's go across the periodic table now to group 6. Okay, so things are a bit different here. This is 2 of the elements in group 6, the only 2 you'll be asked about, which are oxygen and sulfur. And again, I've drawn the atoms of both of these. Okay, oxygen has an atomic number of 8, a mass number of 16, which means it has 8 protons and 8 electrons. Okay, so again, it wants a full outer shell, but in its outer shell, it has 6 electrons. You can see that there. Again, good opportunity to pause the video and draw an oxygen atom for yourself if you don't believe me. It's in group 6. It's got 6 electrons in its outer shell. How does it get a full shell? Well, it's got 6 electrons. So the easiest way to get a full shell is to add 2 electrons. So I'm going to draw in 2 electrons like this. But obviously, oh, that's not a very good electron. There we go. Obviously now that affects the balance of the pluses and the minuses. So overall, it's got 2 minuses more than it has pluses, doesn't it? Because these electrons are negative. So we write that like this, 2 minus. Yeah, put brackets around it and give it a 2 minus charge. So an oxygen has a 2 minus charge like that. And we can do the same thing with sulfur. Sulfur also has 6 electrons in its outer shell. I'm going to add 2 here. And I'm going to put brackets around it and put 2 minus there. And there you go, have a look at that. So oxygen and sulfur in group 6 both form ions which have a 2 minus charge like that. Right, we're going to look at one more group. And the group we're going to look at here is group 7. Right, this is group 7 in your periodic table. And these are the 2 atoms which you might be asked about in group 7. Right, so this is fluorine. It has an atomic number of 9 and a mass number of 19, which means it has 9 pluses and 9 electrons, 2 in the first shell and 7 in the shell after that. So again, to get a full shell, if it's got 7 electrons, remember the octet rule, it wants 8. So we're going to put 1 more in there, then we're going to put brackets around it like that, and we're going to give it a minus charge. And we're going to do the same thing with chlorine. Chlorine has 7 electrons in its outer shell. We're going to put, we're going to draw the electron in first, aren't we? Then put brackets around it like that, and we've turned each of these into F minus and Cl minus. So again, in group 7, atoms form ions which have a -1 charge. Remember, we don't write the number 1 in, we just write minus there once and that does the job. Okay, right. So to summarize all that, what we are talking about here is what's called valency. Okay, valency is the amount of electrons that an atom needs to lose or gain to become stable. So I've summarized it here, as you can see, right? In group 1, each of these elements forms an ion with a +1 charge. In group 2, each of these elements forms an ion with a 2+ charge. In group 3, each of these elements, in this case only aluminium that we need to worry about, has a +3 charge. In group 6, it has 6 electrons, so it'll gain 2, so it'll be 2 minus. And in group 7, it'll be 1 minus. Okay, so I'm just summarizing what we basically went through on the other whiteboards there a second ago. And what happens is that what we're talking about here are ionic compounds. Okay, ionic compounds are things like salt and copper sulfate that we would have looked at. And they involve 2 elements, usually, a metal and a non-metal combining. Okay, now sometimes it's more than 2, but for the purpose of what we're doing, we can think of it as just a metal, something from the left-hand side of the periodic table and something from the right-hand side of the periodic table. And these form ionic compounds or salts. Okay, and the properties of these are really important. They're soluble, they dissolve. Think about salt in water, it dissolves, doesn't it? They conduct electricity when they're dissolved, and they have a high melting point. It's hard to melt salt. It's not easily done in a lab or in the kitchen. Sure, it's not. You've probably never seen salt melted because it's a very high melting point because the forces between the positive ions and the negative ions are very, very strong. So what we can do is we can use this information to write the structure of some of these ionic compounds. For example, what we are going to do is we're going to combine a metal with a non-metal. So I'm going to pick something from group 1, which is lithium, which has a +1 charge. And it's going to react with something in group 7. So I'm going to pick fluorine. And fluorine has a -1 charge. Now the thing about salts is, and we looked at this in the lab, when salts are sitting there as a solid, they're not negative or positive. They weren't attracted to a negative or a positive cathode or an anode or anything like that. They just sit there, they're neutral. And they're neutral because the charges must balance. So in this case, that's really easy. We've got +1 and -1, so we only need one of each. So the formula for lithium fluoride will be LiF. Each is just required once. Remember, we never write the number 1 there. We don't need to do that. We assume that if we've written it, it's there once, right? But If I was to take lithium and oxygen, now oxygen has a 2 minus charge and lithium only has a +1 charge. And I need to balance these two charges. So I'm going to need 2 lithiums for every oxygen, haven't I? Because I'm going to need 2 pluses for every 2 minus. So what I'm going to do is I'm going to write a little subscript 2 in there to show that there's 2 lithiums for every oxygen. Now it's neutral because I've got 2 pluses and 1 2 minus like that. Let's do another example. This is magnesium. It's 2 plus. Okay. If I mix it with an element from group 6, such as oxygen, which is 2 minus, I only need 1 of each. I've got a balance here of the charges, 2 plus and 2 minus. So I can get rid of this, and the formula for magnesium oxide is MgO. But if I take magnesium and chlorine, okay, magnesium is 2 plus and chlorine is 1 minus, now you can see the issue. I've got 2 pluses, but I've only got 1 minus here. So I'm going to need 2 of these chlorides. So I'm going to write 2 in here like that. And now these charges are balanced and I've formed a neutral ionic compound. Now you guys have done a worksheet on this where we went through it step by step, and there's also notes and slides in the folder, hopefully to help you with that. So hopefully these 2 examples and going through this has helped a little bit. I know this is a topic that a few people mentioned they had trouble with. So let me know if this helps and if you have any questions arising from it. Okay, thanks a mil. Bye-bye.